So here we have been asked to find the missing sides. So here we need our m, and we need this side here, the longest side here, the hypotenuse. So this is a right triangle. We have 90 here. We got 45. So obviously here is going to be 45 because 90 minus 45 give us. And now we have learned that this 45 tag 45 tag 90 has a ratio. We have able to discover that. So here we see that we cannot the Pythagorean, because the only type that we need, we know only one side of it, so we cannot apply the Pythagorean. But as we also get into the trigonometry, we can able to apply the tan, sine, and cosine, but we are not there yet. But there is a special stuff that we have able to discover with the Pythagorean, that the 45 tag 90 exhibit some kind of ratio, which is 1 tag 1 tag 1 root 2. So based upon that, we can able to solve this missing side easily without getting into the trigonometry. So here, since we have 45 here, that means the m is also going to 5 based upon here, because it's supposed to be the same 5 5. We know that when we have our 45 and we are looking for the longest side, is just a matter of we multiply by a square root of 2. For us to get the c here is just 5 times square root of 2. So we can leave our answer in the radical form or in the set form like this, and it's fine. In case it's multiple choice and it's in decimal, just multiply on the calculator and you will get your answer. Okay, so let's look at example 2 here. We have been asked to find the k and n. We know only the longest side, the hypotenuse, and we know that here is 45, so therefore here is also going to be 45. When we have our hypotenuse and we are looking for here, we have to divide it by square root of 2. It's like, you know how to drive. When we are driving, we are multiplying. When we're driving, we are going forward here. We multiply it by square root of 2. That's how we got this. So if we got this and we got to go reverse, we have to divide it by square root of 2. So here, for us to find our n, it's going to be 10 divided by square root of 2. And in MEV, we cannot leave our answer in this way. So we have to do what we call rationalization. So we have to multiply numerator by square root of 2, and we have to repeat the same thing here. When we do this, we haven't changed anything, because any number divided by itself is the same. So here is 1, but we need to rationalize so that we can get rid of the radical at the bottom. So here the n becomes 10 root 2, then 2 times 2 becomes square root of 4. Square root of 4 is a perfect square, which is 2. So 2, now we have able to get rid of the radical from the bottom. Now we have a number, and we have a number here, and it's divisible, so we have to simplify that. So when we 10 divided by 2 give us 5. So we have 5, 2 as an answer. So that means here is 5 root 2. And the k congruent to this one. So it's going to be also 5 square root of 2. So here in the near future, if you have been given a question, now we have rationalized it, we can generalize that anytime we are looking for one of the leg in the special, when it's 45 tag 45, we are just multiplying it by square root of 2 times 2. Because when we rationalize square root of 2 at the denominator, we get square root of 2 divided by 2. So anytime you're looking for your 45 side, you can just multiply by square root of 2 divided by 2, and that will get you the answer, and you will not. That's the right concept here. All right. So now we have been asked to find the missing side. Now I want us to get all the 45 tag 45 out of way before we consider the 30, 60. So here in this particular rectangle here, we know that we have 45 here, we got 90 here. So obviously here will be 45, and we are looking for H. We are looking for 45 corresponding H. So we know that the ratio is 1 tag 1 root 2. Here we have been given the hypotenuse. So for us to come here, we got it divided by square root of 2. That's the process. But out of the process, we realize that if we multiply, if we take the hypotenuse and we multiply it by square root of 2 divided by 2, that will get us our answer. Every number is over 1, so we can do that. We are going to get 12 times 2, which give us 24, and it's a square root of that, all divided by 2. We can leave our answer this way, but if you have done how to break down our perfect square, then you can continue to do that to break it down if you know. But if you have not been taught, I believe if you stop here, your teacher will not mark you wrong. But so here we could have break this one down into a perfect square, which is square root of 4 times 6, and that's still 24. And then we divide here by 2. Square root of 4 is 2, so it come out, leaving the 6 behind, and over 2 here. And 2 divided by 2 turn into 1, so we get square root of 6. And square root of 6, we cannot break it down further, so no perfect square can go here, so we can stop here as an answer. Or you can put it in the calculator and maybe get a decimal answer in case that's what your teacher wants. All right, so we have been asked to find the missing sides. Here we see that we have 30 here, we have 90, so obviously here have to be 60. If that is the case, then we are using the special right triangle, which is 30 tag 60 tag 90, and it came with a ratio that we have as it's going to be 1 tag 1 root 3 tag 2. And we said that the 30 is a key. You need it. Other than that, you need, when it comes to this, you need the 30 first. If you're using this 30 tag, 60 tag, 90, you can also use the trigonometry, which is the tan and all that. But if you want to use this thing, the first thing that you need is you need to know your 30. Other than that, you're going to struggle. So here, lucky enough, our 30 have been given us 4. If that is the case, and we are looking for our y, which happens to be the 60, we know that is just, so our y is just going to be 4 times square root of 3, and that's, we are done with that. And then if we are looking for our 90, which happens to be here, then it's just a twice of that, because you see here it was 1 and it's twice here. So here our x here is just going to be 2 times 4, and that's 8, and we are done with that. So here is 8, and here is 4 root of 3. Okay, let's look at this. This one also exhibit 30, 90. So obviously here is going to be 60. If that's the case, we are using the special right triangle 30 tag, 60 tag, 90. And we know that the ratio is 1 tag 1 root 3 tag 2. This is the key. We need this here first. So here we have been given this. That's really good. But we cannot jump it and find our 60. It's going to be really hard. If we want to use this ratios, we have to get our 30 first. So we have to find our f first. So for us to find our f, we know that the previous example, we said that when you're looking for the longer side here, it's just twice of this. So if we have been given this and we are looking for here, it's just we divide it by 2. It's going to be just half of it. So for us to get that, it's just going to be 10 divided by 2, and that gives us 5. So f is 5. And now after we find our f and we need our h, which happens to correspond to the 60, is just, so our h is just going to be the side of the 30 times, so it's going to be just 5 root 3 as an answer. So here is just going to be 5 square root of 3. Okay, so we have been asked to find our t and our m here. So we are considering one of the triangle. We have 90, 60. So obviously here is going to be 30 here, 30 degrees. That means we are using the ratio 30 tag 60 tag 90. And we came with a ratio 1 tag 1 root 3 tag 2. So the 90, the angle 90 corresponds to 10 root 3. Remember, we need our 30 side first. We need our m to make the work much easier. So this is the key. So we need that. So for us to get the m, you see that number is twice of that. So when we are in case we are coming from the 90 to the 30, then we have to be divided. So here has to be just divided by 2. And if we do that, we get 5, because 10 divided by 2, 5, and then we bring our root 3. So m is 5 root 3. We need our t, which is corresponded to the 60. So our t is just whatever that you have for the 30 times square root of 3. So we got 30 to be 5 root 3. So you're going to multiply it by square root of 3. And that gives us 5. So 3 times 3 gives us 9. But square root of 9 is a perfect square, and it gives us, here we are looking at, we are finding the side. So we are looking at the positive side of it. It gives us 3. So here it becomes 5 times 3, and that's 15. So the t is 15. Okay, so let's look at the application questions. So here we have a 60-foot ladder is leaning against a wall, and the ladder makes 45 angle with the building. How far up the building goes the ladder reach? So here we can draw it easily. We can say this is our wall. There is a ladder leaning against it. So here this is the ground, and there is a ladder leaning against it. So here This is the ladder, this is the wall, and that's the ladder. They said they make 45 against the wall. So here is 45. And we know that a building is really perpendicular height. When they are building, they make sure it's perpendicularly height. So here is 90. So obviously here is going to be 45. And now we know the ladder to be 16. And they want us to figure out how far up the building does the ladder reach. So here we want to find here, we can call here, and call it M. We can call here H as a height. So here we see that it's showing 45, tag 45, tag 90, and that's one tag, square root of 2 and 1 here. So now here we know the 90 side of it. So we know the 90 and the 90. So for us to get the H, it's going to be the 90 side of it, which is 16 divided by square root of 2. And we have to rationalize it, and we have already done that. So if you want to get easy peasy way, then you know that when we rationalize it, we are just going to get square root of 2 over 2. So we are just multiplying the 16 times this. So when we rationalize it, that's what we get. So here 16 divided by 2 give us 8 root 2. So if you want, you can use your calculator to find square root of 2. Square root of 2 is about 1.4 something. So you can use that to find that. And then you multiply by 8. That will give you, so if you do that, like the 8 and then square root of that is about 1.4. So if we do that, then we are getting about 11.3 foot over here because there was a unit. And that's how you can able to apply this. Doing that, you could have applied or the sign to do that, but here we are just concentrating on the specials, which is 45, 45, 90 to do that. Okay, so let's look at another example here. So there's 2 wires supporting a young tree as shown below, and they want us to find the length of each wire. Here we realize that we have 45 here, we have 45 here, and here this is 90. This sign represents 90. So obviously here will also be 45 degrees. If that is the case, we can use a special, since that's what we are learning about right now, and become one tag, one root 2, and now we have been given the 45. So it's just going to be for us to find here the 90. So the wire just going to be 4 root 2. And we are done. So each of the wire is going to be 4 root 2. So let's look at this last example here. We have this parallelogram here, and now we want to find BC, which happens to be here, and the AB, which is here. So here we see 30 here, and this symbol represent 90. So here is 60. If that is the case, this is a special right triangle, which is 30 tag 60 tag 90, and it comes out with a ratio 1 tag 1 root 3 tag 2. So here we see this symbol. This symbol represents the congruent. So they are saying that this length here, the DE, so here the DC is congruent to AC. That's the meaning of that symbol right there. It was part of the question. That symbol was part of the question. So here we know that here is going to be 30. So the 90 is 30, and we need to find our 30 angle 30 first, because that's the key. That's always the key that you need. So here we realize that twice the angle 30 give us angle 90. So therefore, if the 90 is corresponded to 30 centimeters, then our BC, our length BC will be 30 divided by 2, and that gives us 15 centimeters. And after we get that, then we can able to find our AB. Our AB corresponded to 60, angle 60, and we know that angle 60 is just the 30 times square root of 3. So here